Welcome back. Today's video is about trigonometry. It's a mathematical introduction about things that you will need to continue moving forward in physics. So first I'm going to do a quick review of geometry that is going to be very helpful for us. So I'm going to talk about right triangles. If you remember from your geometry classes, right triangles are triangles where one of the angles is 90 degrees or a right angle. So it looks like this. The right angle, the 90-degree angle, we always mark it as a square to show that that is 90 degrees. And then we have two other angles in the triangle. We have this one down here and this one up here. We can call them theta. Theta is this Greek letter that looks sort of like an O, but it has a line in the middle. So this one we can call theta 1, and this one we can call theta 2. And something that is true for all triangles is that their three angles add up to 180 degrees. So let's write what we know until now. We know that right triangles have one 90-degree angle, and we know that all angles add up to 180 degrees. So if we take into account the fact that in our triangle, one of those angles is 90 degrees, we have the following equation. The 180 degrees total have to be equal to the 90 degree that we know plus these two angles over here, theta 1 plus theta 2. This is just the mathematical way of writing this rule. So we can actually subtract the 90 on this side, and what we're left with is that for right triangles specifically, the two angles that we don't know have to add up to 90. So if for example I tell you that this angle is 30, this other angle has to be 90 minus 30, which is 60. We also have a way of figuring out the lengths of the sides. We will call this one A, we will call this one B, and we'll call this one C. If we know two of the sides, we can figure out the other one with something called the Pythagorean Theorem. The Pythagorean Theorem says the following. It states that A squared plus B squared equals C squared. So now what we're going to do today is give names to those letters. So in our right triangles, you can notice that there's always one side that is the longest one, and it's opposite from the 90-degree angle. That one we're going to call the hypotenuse. So C is the hypotenuse. If you wanted to solve for the hypotenuse with this equation, you would have to take the square root on both sides, and you would know that the hypotenuse is the square root of A squared plus B squared. Now, when we pick an angle, either theta 1 or theta 2, we can give names to the other two sides. So let's pick the angle at the bottom. So we have a side A and a side B. One of those we're going to call the adjacent, and the other one is going to be called the opposite. The names give you tips on what we're talking about. So when we're talking about opposite, what we're saying is that that side is opposite to the angle that we're talking about. In this case, we're talking about this angle, so the opposite side would be side B. In this case, the opposite is B, right? So it's opposite to the angle. That means it can't touch the angle. When we're talking about an angle, in this case, this one, it's made out of two lines that come together at that point. In this case, the angle is formed by this line and this line. The side B, the opposite side, will never touch the angle. So let's write that down. Opposite to the angle, never touches it. The other side that we have is the adjacent. It's called adjacent because it's adjacent or beside the angle. So the angle is always formed by the hypotenuse, C, and by the other side that we call adjacent. So in this case, side A is our adjacent. And it's the adjacent because it makes up the angle and it's beside it. But don't memorize that the adjacent is always the side on the bottom and the opposite is always the side that is vertical. I'm going to draw many examples of triangles, and we'll try to find which side for a given angle is the adjacent, which one is the opposite, and which one is the hypotenuse of the triangle. So the hypotenuse never changes. The hypotenuse is always the longest side, and it's always opposite the 90-degree angle. But the adjacent and the opposite can switch depending on if I give you the angle on the bottom or I give you the angle on the top. So let's do some examples. Okay, so here I drew 8 triangles, and we'll try to find the hypotenuse, the adjacent to the angle, and the opposite to the angle in each one. So what we do first is find the 90-degree angle that is labeled by a square, and the opposite side to that will be the hypotenuse. So I'll put HIP for hypotenuse. In this case, this one is the hypotenuse. Then we find the angle that we're given. In this case, the angle is this one on the bottom. The opposite to that will be the opposite side. And the other side that makes up the angle, that opens up the angle, is the adjacent. So I'll put ADJ for adjacent. On the second one, so again, the hypotenuse is right in front of it, and it's the longest side. The opposite is on the other side of the angle. So in this case, it's to the left. And the one that makes the angle is the adjacent. If you think you're getting it, you can pause the video and try to figure out for each one and then check your answers. So here, the hypotenuse, usually it's drawn as a diagonal, but we'll see that not always. The opposite to the angle is opposite. The side that makes up the angle is the adjacent. Here we have the opposite to the right angle is the hypotenuse, the opposite to the angle is the opposite, and the side that makes up the angle is the adjacent. Here it's a little bit different. Here the triangle has the right angle at the top, so you need to be careful where the right angle is. So here it's at the top, which means that the opposite side to the top is the hypotenuse. So in this case, the triangle is lying on the hypotenuse. The side that is opposite to the angle is called opposite, and the side that makes up the angle is adjacent. Here we have, again, the opposite to the right angle is the hypotenuse, it's the longest side. We have the opposite to the angle is here on the left, and the one that makes up the angle is the adjacent. Here again, this would be the hypotenuse, this would be the opposite, this would be the adjacent, and here we have the hypotenuse, the opposite to the angle, and the adjacent to the angle. So you just need to make sure you know where the right angle is and where the other angle is to label the sides. So now that we know how to determine which side is which, we're going to define something called trigonometric functions. There are 3 basic trigonometric functions, and they're called sine, cosine, and tangent. Sine, cosine, and tangent. Because they are functions, functions means that you have to put something inside it. You need to evaluate at some point. So usually our functions that we know are in the x-y axis, right? So we have our x and our y. And the function, for every x, it has a y. Every x has a y. But in this case, sine, cosine, and tangent are not evaluated based on x. They're evaluated based on the angle theta. So they are functions of the angle theta. If the angle changes, the value of the sine, cosine, or tangent change. So these trigonometric functions are actually ratios of the sides of a right triangle. Let's define them to see if this makes sense. So we have sine, which we write the first 3 letters of, and in our parentheses we put the angle, because that means that we're going to evaluate the sine function into the angle theta that we put into it. And the sine is defined as the opposite side of a triangle over the hypotenuse. So opposite over hypotenuse. Cosine, and we put again the first 3 letters, and we're going to evaluate it at an angle theta, is defined as the adjacent side of the angle over the hypotenuse of the triangle. In tangent, we put the first 3 letters, we put inside the angle theta, and that's going to be equal to the opposite side over the adjacent side. So these are the definitions of the 3 trigonometric functions. In order to remember which trigonometric function uses which side, mathematicians came up with a word that helps us remember, and it's Sohcahtoa. So Sohcahtoa is made of the letters of each of these words. So S stands for sine, so O stands for opposite, and H stands for hypotenuse. Then we have Ka, the C stands for cosine, A for adjacent, and H for hypotenuse. And Toa, the T stands for tan, the O stands for opposite, and the A for hypotenuse. So if you remember the word Sohcahtoa, and for example I ask you, which ratio of sides is cosine? Then you look for Ka, and you see that it's adjacent over hypotenuse. So that's just a word to try to help you remember the definitions of sine, cosine, and tangent. So let's put this into an example to see if it makes a little bit of sense. So suppose you're given this triangle as an example. You're given three numbers. You're given the size of this side, which is 4, the size of this side, which is 2, and this angle down here, which is 30 degrees. And you also know it's a right triangle because you have the little square. So the first thing we want to do is identify which side is which based on this angle here that we're given. So first we identify the hypotenuse, which as always is the longest side, and it's the opposite side from the 90-degree angle. So here our hypotenuse will be 4. Now this number 2 is on the opposite side of the 30-degree angle. So based on where the angle is, this is going to be the opposite side. And this one down here forms the angle, it makes the angle, so it's going to be the adjacent side. So first we can realize that we're missing the size of the adjacent side. We weren't given this number, but we need it. So what we do is we use the Pythagorean Theorem. So we know that the Pythagorean Theorem says that a squared plus b squared equals c squared. Our a can be the adjacent, so that's what we're looking for. And we put in b the 2, so this is 2 squared, and in c the 4, so this is 4 squared. So we have a squared plus 2 squared is 4 equals 4 squared is 16. And then we can pass and subtract the 4. So we have a squared equals 16 minus 4, which is 12. So a is the square root of 12. We can put that as a decimal, but we can also leave it as square root of 12. So now we figured out that the adjacent side has a length of square root of 12. We can put it in our triangle. Now let's try to calculate the sine of 30, the cosine of 30, and the tangent of 30. So how do we use these functions? What we do first is write down sine of 30. So we put sine, and always inside of the parentheses, we're going to put the angle. Because we're talking about this angle over here, we change the theta for 30 degrees. Equals. So we go back to our definition. Our opposite side, in this case, is 2. And the definition is opposite over hypotenuse. So we put 2 over, and the hypotenuse is 4. So what we got here is that the sine of 30 is equal to 1/2. Actually, if you put it in your calculator, there's a button for sine. If you press sine and you put 30 inside of the parentheses, it'll give you 1/2 or 0.5. So until then, we're doing things right. Now let's try to find cosine of 30. So we can still use our triangle. The cosine of 30 degrees will be equal to, according to the definition, adjacent over hypotenuse. The adjacent was square root of 12. And the hypotenuse is 4. So that is a decimal, but we can also just state it as square root of 12 over 4. And the tangent of 30 degrees. So we go back to the definition. Tangent is opposite over adjacent. The opposite was 2 over the adjacent, which is square root of 12. So just by using the triangle, we were able to calculate the sine, the cosine, and the tangent of the angle 30. But this same triangle over here also has an angle on top. And because of our rule that all triangles have to add up to 90 degrees, we know that if this angle is 30, this one has to be 60, because 60 plus 30 is 90, plus 90, 180. So we also know that this angle is 60. But if we're talking about the angle up here, even though the hypotenuse will always be the hypotenuse, now the opposite would be this one. So even though square root of 12 was the adjacent side to the angle 30, it's the opposite side to the angle 60. And the opposite to the angle 30, the 2, is now the adjacent side to the angle 60. So remember that the sides, how you call them, depend on the angle that you're looking at, even if it's part of the same triangle. So using that, we can now calculate the sine, cosine, and tangent of 60. So the sine of 60, we can use the same triangle, but now looking at the green labels. So sine was opposite over hypotenuse. The opposite to the angle 60 is square root of 12 over the hypotenuse, which is 4. So the sine of 60 is equal to the cosine of 30, not to the sine of 30. Now we have the cosine of 60. The cosine of 60, according to our definition, is adjacent over hypotenuse. So the adjacent to 60 is 2, and the hypotenuse is 4, which is 1/2. So the cosine of 60 is equal to the sine of 30. You can also check this with your calculator. And finally, the tangent of 60, tangent was opposite over adjacent, so we have opposite, square root of 12, over adjacent, which is 2. So notice it gave us the inverse of tangent of 30. So tangent of 60 was square root of 12 over 2, tangent of 30 was 2 over square root of 12. So you have to be very careful when you label the sides that you're labeling them correctly for the angle that you're being asked for. Now let's do this second example, which is a little bit harder. So here we're given a triangle where the angle is still 30, but we only have one side. We're only given the hypotenuse. So we can't use the Pythagorean theorem to find out this side or this side. We're going to have to use something else, because for the Pythagorean theorem to work, we need two sides to solve for the other side. So what can we do? We can actually use the trigonometric functions and solve for the side that we're missing. So for example, we have the hypotenuse, and let's say we're looking for the opposite side. We need to find one of the functions that has opposite and hypotenuse. So you look, this one doesn't have hypotenuse, this one doesn't have opposite, so the only one we can use is sine. So what we put is sine of the angle. We know the angle is 30, right? And then we equal that to opposite over hypotenuse, but we don't know the opposite, so we have to leave it as opposite over the hypotenuse, which in this example is 3. So turns out that this sine of 30 is always the same thing. You can put it in your calculator and it'll always give you a number. If you put it in the calculator, you'll see it gives you 0.5, like we did in the previous example that gave us the sine of 30. So you can change this for 0.5. So we're left with an equation that is 0.5 equals opposite over 3. That means that we can solve for opposite multiplying this 3 here. So 3 times 0.5 is equal to the opposite. That means the opposite is 1.5. So we figured it out. This side measures 1.5. Now we're also missing the adjacent. And we have the hypotenuse and we have the opposite. So we can't use sine because sine won't give us adjacent since it's not in the equation. But we could use cosine and hypotenuse to figure out the adjacent. Or we could also use tangent and the opposite that we already know to figure out the adjacent. I'll just be using cosine because I think it's easier. So we also know that cosine of 30 is equal to, because of its definition, adjacent that we're figuring out, over the hypotenuse, which in this example is 3. And cosine of 30, if you put it in a calculator, you'll see it's close to 0.87. So you can say 0.87 equals adjacent over 3. And to solve for the adjacent, you pass the 3 to multiply over here, and you get 3 times 0.87, which will give you around 2.6. So now that we have the 3 sides, we could actually calculate the tangent of 30. And since we also know that this triangle has an angle of 60 here, we could also calculate sine of 60, cosine of 60, and tangent of 60. And we could also use the Pythagorean theorem, now that we have 3 sides, and check. So if you put in your calculator, you should get that 1.5 squared plus 2.6 squared is equal to 3 squared. If you try it out, you'll get that. So when you do the work for today, you're going to have examples in which you need to figure out one of the sides when you're given 2 with the Pythagorean theorem. Examples where you have to say what the sine, cosine of tangent of an angle is using the sides that you're given. And you're also going to have examples where you need to solve for one side because you have the angle and the other side. So for this, you just need to remember to pick the function that works for you based on what you have and what you're looking for.